Solving trig equations. So far, we have simplified trig expressions using identities and also used identities to prove trig statements. Now we will solve trig equations using the identities we have learned. To solve a trigonometry equation, apply the rules of algebra to isolate the trig functions. Some will require using a trig identity, or 2 or 3, while others are more simple, like the one below. Solve. 2 cosine x minus 1 equals 0. Alright, so first we add 1 to both sides and then divide both sides by 2. So we've isolated the trigonometric function on the left and 1/2 on the right. Then we take the arc cosine of 1/2, giving us possible solutions of positive or negative pi over 3 plus 2k pi, where k is an integer. Solve. Cosine x squared plus 1 equals 2 cosine x. Okay, so first we're going to subtract 2 cosine x from both sides, moving everything over to the left side, and we have that set equal to 0. Then we're going to factor this, take the square root of both sides, and we have cosine x minus 1 equals 0. Add 1 to both sides, and we have isolated the trig function on the left. Then we take the arc cosine of 1, and we see our possible solutions are 2k pi, where k is an integer. Solve. 2 sine x squared plus 6 equals 8. First, we subtract 6 from both sides, and then we're going to divide both sides by 2, then take the square root of both sides, and we see that sine x equals positive or negative 1. Therefore, the solutions for x are positive or negative pi over 2 plus 2k pi, where k is an integer. Solve. 2 sine x squared minus sine x minus 3 equals 0. Our first step is to factor this, which we've done here. Then we set this piece equal to 0 and this piece equal to 0. Over here, we add 3 to both sides, divide both sides by 2, and we get sine x equals 3 over 2, which is 1.5. So therefore, there's no value for x that has a sine value of 1.5 since the maximum value for sine is 1. So x is undefined. Over here, we have sine x plus 1 equals 0. Therefore, sine x equals negative 1, giving us solutions of negative pi over 2 plus 2k pi, where k is an integer. Solve. 1 plus cosine x equals 2 sine x squared. First, we'll use the Pythagorean identity to replace this sine x squared with 1 minus cosine x squared. Then we're going to multiply each of these by 2, and then move everything over to the left side and factor. Once we do that, we set each piece equal to 0. Here we have 2 cosine x minus 1 equals 0. Therefore, 2 cosine x equals 1. Divide both sides by 2, and we have cosine x equals 1/2, giving us possible solutions of positive or negative pi over 3 plus 2k pi, where k is an integer. And over here, we have cosine x plus 1 equals 0, cosine x equals negative 1, giving us solutions of pi plus 2k pi, where k is an integer. Solve. Cosine x minus sine 2x equals 0. Okay, so first we're going to use an identity to replace sine 2x with 2 sine x cosine x. Then we're going to factor out cosine x. So now we have cosine x times 1 minus 2 sine x. Since that's equal to 0, we can set each of these pieces equal to 0. Cosine x equals 0. Therefore, we have possible solutions of plus or minus pi over 2 plus 2k pi, where k belongs to the set of integers. Over here, we have 1 minus 2 sine x equal to 0. Therefore, sine x equals 1, giving us possible solutions of pi over 2 plus 2k pi, where k belongs to the set of integers. Solve. 1/2 equals sine of x over 2. First, we use our half angle identity to replace sine of x over 2 with the square root of 1 minus cosine x over 2. Then we're going to square both sides to get rid of this square root. And then we're going to be solving for cosine x. So first, let's multiply both sides by 2. And then we're going to subtract 1 from both sides. And then we're going to divide both sides by negative 1. We have cosine x equals 1/2. Therefore, we have solutions of plus or minus pi over 3 plus 2k pi, where k is an integer. Solve. Negative cosine x plus sine 2x equals 0. First, we replace sine of 2x with 2 sine x cosine x. Then we factor out a cosine x, and we have cosine x times negative 1 plus 2 sine x. Then we set each of these pieces equal to 0. Cosine x equals 0, therefore x equals positive or negative pi over 2. And over here, we have negative 1 plus 2 sine x equals 0, or sine x equals 1/2, giving us x values of pi over 6 and 5 pi over 6.